Hello everybody, welcome to the Python course. In the previous lecture we have covered module 12, that is Introduction to Pandas. In this lecture we will start with module 13, that is Introduction to Matplotlib and Seaborn libraries. So friends, these are also the libraries similar to our pandas, but the only difference between your pandas and your Matplotlib is that there are the visualization libraries. They tell us how we can represent your data. In this part, we'll cover some of the charts and plots that can be plotted by using these libraries to know our data representation better. So we will be covering majorly two libraries, that is Matplotlib and Seaborn. In this part of this lecture, we will see only Matplotlib. In the next part, we'll see the Seaborn. So let's start. So I have already opened up my Anaconda navigator and opened up my Tonic folder. So here we'll create a new Python 3 notebook and we'll name as module 13 Matplotlib. Right? Okay. So in this part, we will learn how to create the basic plots using our Matplot library. So the major plots we will see our scatter plots, histogram and bar plots. So let us discuss one by one what are scatter plots, what are histogram and what are bar plots. So before learning the plots, let us learn why data visualization is important. Right? So data visualization allow us to quickly interpret the data and adjust the different variables to see their effect. Right? For example, we have our large CSV file which consists of thousands or 20,000 or millions of records. Right? So by data visualization, it gives us a quick interpretation how my data points are behaving, whether the trend is going upward, whether the trend is going downward, whether it is a constant rate. Right? So with this huge volume of data, one cannot easily interpret by looking it directly into your Excel files or reading into your pandas data frame. So we need some kind of a visual representation or kind of a storytelling so that we could look at it and we could come at some point of analysis. Right? So to observe the patterns and to identify the extreme values that could be anomalies also. So data visualization is used for the easy interpretation of your data, right? How you can interpret your data and you can tell it to your stakeholders, right? You can formulate a story and you can express your data in terms of your story points and you could display your data to your end customers, right? So that's why data visualization is very important. So what are the popular plotting libraries that are used in Python? So Python offers a multiple graphical libraries that offer diverse features. So starting from your Matplotlib that is used to create 2D graphs and plots, and then we have your Seaborn library also. It provides a high level interface for drawing attractive and informative statistical graphical points and graphical figures, right? Okay. So based on this, there are few advanced libraries, plotting libraries such as ggplots or plotly, which can have thousands of features which could give you a better representation of your data, right? So let's stick to the basic libraries, that is Matplot and Seaborn, that we will be covering in this lecture series. Okay, so let us understand what is Matplotlib. So it is a 2D plotting library which produces good quality figures, right? So it has its origins emulating in the MATLAB graphics commands, right? And it makes the heavy use of NumPy and other extension code to provide performance for even larger arrays, right? So the basic one, you can say that to start with your data science and your Python, so you can use your Matplotlib library, and then you can further move to your ggplots or plotly library, right? The only difference between these graphical based libraries is that so it offers a wide range of your tools and interactive features, which makes a colorful graphical representation, right? Okay, so let us discuss what is scatter plot. A scatter plot is a set of points that represents value obtained from two different variables plotted on a horizontal axis and the vertical axis, right? Suppose we wanted to convey a relationship between two numerical variables x and y. So we wanted to see how these variables are being represented graphically, whether the trend, if x increases y also increases, or if x decreases y also decreases, or the vice versa, if x increases y decreases. So these are kind of relationship we wanted to find between our two different variables, and by plotting onto the horizontal and the vertical axis we could convey that relationship, right? So the scatter plots are sometimes also called as correlation plots, because they try to give us a interpretation what is the relationship between two variables, right? So how they are closely correlated with each other, right? Okay, so to use the scatter plot or to find the relationship between two variables, so we need to import the matplotlib library, right? So we need to import matplotlib.pyplot, right? So this kind of library, we are saying that we need to pyplot that part. So it is a library which is used to import, and this is the alias name as we have already seen in NumPy and pandas, right? So these are the three major libraries we need to import before working with your data, right? So NumPy is for use for numerical computations. Pandas, you can convert your CSV into your pandas or series object, and for matplotlib you need to plot the graphs or the visualizations, and you need to show the relationship between your variables, right? So that is how you can import these libraries, right? So here we have already seen the importing of the data in our previous lecture, right? So we have taken a Toyota set.csv, right? So this data set consists of 1436 rows and 10 columns, right? And we have also dropped the NA, right? And which makes us to drop the rows, and the rows resultant size is your 196 and 10 rows, right? So this we have already seen to make it at index 0 position, right? So and NA values, so this NA values are being replaced, so junk values are being replaced by NA values. So this is how we import our data, right? So let us see this in practice, right? So we have already created our module 13 notebook. So now I am importing our pandas as PD, import numpy as np, import matplotlib dot pyplot as plp, right? So now run these cells. Now these libraries have been imported to your Jupyter notebook, right? So now, so I will take data equal to pd dot read underscore csv, right? So let's take this Toyota dot csv, and this has the index underscore column equal to 0 and NA underscore values equal to right. So we have removed all the NA values, right? And now we can see data dot head, or you can also see data dot describe. Okay, So let's use info method. Okay, so this is your info method, right? So it says your columns are price, age, kilometer, fuel type, HP, matte color, automatic, CC, doors and weight. Okay, and the data types of integer, float, object, right? So these are the data types, and it has got 1436 nominal values, right? And total entries are 1436 rows, and basically we have our 9 columns, so 0 to 9, right? So that makes it 10, total of 10 columns and 1436 entries, that is rows, right? Okay, so now onto this data I'll drop the NA values, right? Drop NA, right? X is equal to 0 and in place equal to true. The in place is used that so that we can modify the changes in the original data set, right? So if we wanted to make it at another data set or make a copy of that, then you can use it assignment operator and give the value of a particular variable, and then all these values will be stored in that particular variable. But it's better to recommend if you doing in place, so all these transformations take place in this data object only, right? Okay, now we have done this part. Now if I run the info again, now you can see that we have 196 entries, 1096 entries, and we have around 10 columns, right? So this is how our data looks like, right? And all the null values have been replaced, all the junk values has been replaced to NA, and we have also deleted our NA values. So now the data set is clean, so we have cleansed our data set, right? Okay, so this was the objective, so we need to cleanse our data set. So now you can see that the size, original size was 1436 and it has been reduced to 196, right? 1096. Okay, now we'll do the scatter plot. So as I've already told that scatter plot gives you a relationship between your two variables, right? So this data set, let us first try to understand what this data set is, so that you can have a overview of it. So this is the data set of a Toyota car data set, right? So what it basically says, it has the price, the price of the car, the age of the car, kilometers, fuel type, HP, that is the matte color, that is automatic, that is 0 or 1, that is how many cc, how many doors are there, and its weights. So basically it gives you all the features of a car, right? And also based on these features we have the price also, right? So there is a price column also, right? So we wanted to find the relationship between the price and the age. We wanted to find the trend, right? So as we already know that the old car, if you try to sell your old car, so old car, right, the price depends upon the age, right? So it's a negative correlation part. You can say that if the age is less, price is higher. If the age is larger, the price is smaller, right? So if you are trying to buy a new car, the price would be higher. Even if you are trying to buy an old car, the price would be gradually lesser than the original price. So this is a trend we wanted to find out, and by visual representation we wanted to express these entities into our graphical representation, right? For that we need to make our scatter plot. So here we are trying to find the relationship between the age and the price of our cars underscore data, right? And the color of the data points could be red, so you can make it any color you want green, red, blue, etc. You can change it in a C parameter. And this is title. You want to have a title, that scatter plot of price versus the age of the cars, and we have the X label, that X, the label which comes under the X axis, Y label, the label which comes along the Y axis, and in the end we want to display it in our Jupyter notebook, and for that we have our plot.show, right? So basically it is a matplot library. We are calling different functions of the matplot, that is scatter, title, X label, Y label, and show. So on this 5 lines of code we are displaying our scatter plots. So let us see. Okay, so plt dot scatter, right? So I will say data comma age, data comma that is price, right, and c equal to red will be small dot title. So I will change the title to relationship between age and price, right? So plt dot x label, along the x label there is a age column, and plt dot y label is along the price label, right? Then we have plot dot show. Now you can see that, right? So there is a age column in this part, right? So as the age increases, right, your price is less. So you can see that. So 5,000 to 10,000. So if the age is higher, so this range correspond to that part, and if the age is between 0 to 10, we have the highest range, around 30,000, right? So this is how you can show your relationship between your age and price, right? Show your scatter plot and represent your data in terms of your graphical representation, right? Okay. So we can make it or interpret through this graph that the price of the car decreases as the age of the car increases, right? We can also visually see the same thing. So that's why we have come up with this interpretation, right? The next part we will be covering is histogram. Let us try to understand what is a histogram, right? So it is a graphical representation of your data using bars of different heights. So in this histogram we have bars which represent different heights, and the histogram group numbers into ranges, and height of the each bar depicts the frequency of range or bin, right? It is basically the frequency distribution of your numerical variables. Remember guys, we have seen value counts in our pandas data frame objects, right? So series objects, you can see that there is a function called value count. So what it does, it represents the frequency distribution of your variable, right? So similar distribution you try to find out via using your bar plots, or sorry, histograms, or using your bars of different heights. So that is why histogram come into picture, right? So histogram, we wanted to plot the data of the cars in terms of your kilometers, right? We wanted to know like how many cars, right, how many cars are there which travels like kilometers, like which have traveled highest kilometers, or right between some range. For example, you can see that like the cars like which have there are around 300, more than 300 cars which have traveled close to between the range of 50,000 to like 1 lakh, right? So you can make an interpretation, so this is the intensity, this is the frequency, right? Okay, right? Also you can also show that you can also make it a bin, right? So you can give it a color, edge color. So edge color is basically used to represent your curve, that this curve is representing your this much intensity between 0 to 50,000, and 50,000 to 1 lakh, it is around close to 500, right? More than 500, right? Number of cars which have traveled, right? Okay, so let us try to first plot with default arguments, then we'll see the arguments. So there's a plot.hist, and we need to define only one variable because it is a frequency count of that particular variable. So plot.hist. So here what we'll see, plt.hist, and here we'll see data.kilometer, and then we'll say plot.show. Right, so here you can see that there is a normal part in which we have shown the distribution. Right, so for example, if I say plot.hist, and in that part I'll say data per kilometer, right, then I say bins equal to 5, and then edge color equal to white. Right, so now you can see it, graphical representation is much better than your previous one because it was combined. Here we have specified the edge color, so it gives you a separation between your data points, that is around 0 to 50,000. There are around close to 300 and 320 or 340, you can say that, and between 50,000 to 1 lakh there is a more than 500. So the frequency distribution between this range is much larger as compared to other ranges, right? So this you can make an interpretation, right? So okay, so similarly you can also title it. So title histogram of kilometers, X label, Y label, and show that part. So here if you wanted to plot.label histogram of kilometer, plot.x label, right, kilometer traveled, or you can say that simply kilometer, Y label, number of cars, right, okay, here I need to say title, sorry. Okay, so here this is the title, that is histogram of kilometer. Here I represent kilometer, right, this is the number of cars, right. So kilometer range or kilometer, so anything you can represent based on your choice, right. Okay, so then the next is bar plot. So what is a bar plot? So bar plot is a plot that represents the categorical data, right. So this is also similar, in which we could represent your categorical data with rectangular bars and with length proportion to the counts they represent, right. So there's a like histogram and bar plots is basically the same, but histogram is used to represent your numerical data with the frequency count distribution, and bar plots is used to represent your categorical data, right, with the rectangular bars, similar to your histograms also, and it also gives you the frequency codes, that how many categorical variables are present in this part, right. So it makes it easy to compare sets of data between different groups. So we wanted to categorize male and female. So how many numbers of female are there, how many numbers of males are there. So this way we need to represent our data, so that could be represented by using a bar plot, right. For example, here in this part you can see that there is a petrol, fuel type, diesel and CNG. We wanted to find out how many number of cars are there in the petrol variant, how many number of cars are there in the diesel variant, and how many number of cars are there in the CNG variant. So you can also find out by the length of fuel type, right, and you can find out, right. But here there's a value count also, right. So there's a value count that gives you the representation of your petrol, diesel and CNG variants and how many cars are there, right. Here you can also write your index, right. So this index is basically your length of your fuel, and this count is basically your count of diesel, petrol and CNG, right. So it gives you frequency or distribution of your fuel type, right, and right. Okay, so now you can see that petrol has the largest frequency, diesel has the lowest frequency, as compared with petrol, and CNG has the even lowest, that are very less, right? So basically, right, so this is how our bar plot works. So like, let me first give you data equal to okay, fuel type, okay. So now this is how we get a data, right? You have the petrol, in petrol you have the 968, and diesel you have 116, and CNG you have 12, right? So this is how you can get your value counts. So in 0 you can get 968, right? So I'll take this part in your values, and it will contain in your list values, right? So here all the right, so you can see, so this data has been represented in your this part. So let me try to write it formally. Okay, so let's stick with this. Okay, nine six eight comma 116, then 12, right? So I take an index also. So index is your np dot range. Okay, here we have fuel type. We have categorized the fuel type into 3 categories, that is petrol, comma diesel, comma CNG, right? Fuel type is not defined. Okay, sorry, length of this part. Okay, so now what we'll do to represent your bar plot, so there's a function called plt.bar. Here we specify the index, and here we specified the height of the bars, that is the counts. So here in this part we have the values, right? And here we represent it. Yes, so plt.bar, so we represent your index, and then we'll represent your values, right? So then we'll show plot.show. So here, right, so it is being represented. So now I'll try to give the title, right? Car variants count. So you have different car variants, that is petrol, diesel and CNG. We'll have X label, and we have plt.y label, right? In the X label we have the frequency types, you can fuel types, you can say that fuel types. In the Y label we have the frequency, right? So you have the fuel types, and here you could have the, right? Okay, so this is how you can represent your bar plots, right? Okay, so in the next part we will be covering your Seaborn library. So in this part we have covered our basic matplot library, and we have seen our scatter plot, histogram and bar plots, right? So thank you guys, thanks for watching. Stay tuned for our next tutorial.